But wherever you go, I mean, there are green issues being talked about. Everybody wants to be seen to be green. And everybody wants to know what's green and what isn't green. But I'm afraid there isn't a simple answer. It's very difficult to say. All we can try to do is move in a greener direction. And in doing that, I always say, whatever sector you're in, do be aware of the life cycle issues. Because the reality is there's so many pressures on chemicals these days. And, you know, we are ultimately talking about making chemical entities. So we are talking about chemicals. And unfortunately, a lot of people have got very negative views about chemicals, which influence legislation. There's all sorts of real issues now at stake with regards to chemicals that weren't there when green chemistry started. I mean, it's interesting to go back in time and think back, you know, in terms of where this all came from. And certainly my first awareness of the area goes way back to the late 1980s, and we were publishing papers on what we called environmentally friendly catalysis. And there were people already doing some very interesting efforts to try and find greener ways of doing very important reactions like Friedel-Crafts, oxidations, and so on. And then in the early 90s, the US EPA, that was a very proactive organization at the time, decided they wanted to encourage the chemical industry in particular to move in a greener direction, especially to reduce waste. The big focus was on waste. I'll come back to waste in a moment. And what happened was the EPA started up something called the Green Chemistry Presidential Awards, which still run today, very successful program, which awarded industry and inventors on things that were considered to be green. It encouraged green chemistry through awards programs, and there was a guy called Joe Breen at the time I got to know very well, who was encouraged the movement. He had a protege called Paul Anastas. Paul, staying in the EPA, then got to working with John Warner, who was working in industry at the time, and they got together to create the 12 Principles of Green Chemistry, which of course you've already seen listed, and which has become very much the kind of the philosophy underpinning the area of green chemistry. But in those days it was very process focused. Really, people were interested in manufacturing of chemicals. They were looking at the middle of the life cycle. They weren't really thinking terribly much about raw materials. They weren't thinking terribly much about products. Although you see the principles do make references to those, you'll also notice that the vast majority are focused on chemical processing. If you wrote them again today, you would undoubtedly have a different balance between them, because nowadays, of course, we're very concerned about resources and we're very concerned about products. And we have legislation to support that, and we have reality in terms of availability and so on, which I'll come on to a bit later with regards to resources. So there's all sorts of factors, and I always say, whatever you're doing, try to think like, don't try and do an LCA every time you move, otherwise you won't make any progress at all. But try and be life cycle aware. When you're introducing a new catalyst into a process for good reason, try and think about it from the point of view, what are the resource implications of switching to this catalyst? What are the possible end-of-life implications when it comes to, say, the waste that will come out of the process? Because everything eventually, remember, will end up in the environment.